Chapter 13, Water-Soluble Vitamins, Screencast 1. Now, the previous chapter focused on lipid-soluble vitamins, and this chapter will be focusing on water-soluble vitamins. Now, keep in mind, as vitamins, they do share some things in common. They are organic, and they are both essential. But there are some very significant differences that go beyond their solubility. One thing to keep in mind is they are much more easily destroyed by cooking. And when cooked, the possibility is for them to leach the nutrients into the water that's being cooked with. Retention is greatest when using techniques such as stir frying and microwaving, and these are techniques that actually limit exposure to heat and water. Now, a food's vitamin content can also be destroyed by factors such as heat, light, air, and alkaline substances. Now, here, one of the things that I want to point out are all of the functions of vitamins and choline do. Now, please keep in mind that this is not something that you need to memorize. And the other thing that you kind of have to remember here is that all of these processes are using both water-soluble vitamins, lipid-soluble vitamins, and choline. So all of them, they play a role in blood formation, protein and amino acid metabolism, antioxidants, the expression of genes, immunity, carbon metabolism, bone health, and overall energy metabolism. And this is something that we should remember when we were going over Chapter 9. Now, this table here is talking about various tips that you can use to preserve the nutrients in foods so that when you're cooking or storing them, you are not going to lose a lot of the nutrients, mostly vitamins, that are found in these foods. For example, fruits and vegetables need to be kept cool until eaten, and the reason why is enzymes in fruits and vegetables begin to degrade vitamins once they are harvested. Chilling limits this process. So that's just one example of things that you can do to increase the amount of vitamins in the foods that you have. Once again, I'm not going to go through all of these, but I think it is important to understand some of these, and so you might want to practice some of these techniques on your own, knowing that it's better at preserving the vitamins in the food that you are purchasing and plan on eating. Now, all B vitamins form coenzymes, and coenzymes are small organic molecules that are cofactors combining with inactive enzymes to form active enzymes. They function very much in energy metabolism, so individuals that are participating in a lot of physical activity, they probably are going to need more B-complex vitamins due to the demand from the activity. In foods, B vitamins are present as vitamins or coenzymes. In some cases, they are bound to protein, so they need to be free to actually be absorbed in our body. Unbound vitamins are the main form that are going to be absorbed. In this image here, we actually see the importance of a vitamin coenzyme. We see that the enzyme itself is inactive and is not activated until it actually combines and interacts with the inactive enzyme. Now, one thing that this table is demonstrating is the role of various B vitamins and how important they are as coenzymes. Now, please keep in mind, I'm not asking you to memorize all of these vitamins and the coenzymes that they are, but we have already addressed two of these, specifically riboflavin and niacin, and in Chapter 9, we talked about the role that they play as electron transport molecules. Now, this table here is actually demonstrating how important vitamins are in all metabolic processes. Regardless of the substrate, it is impossible to completely metabolize either glucose or glycogen, triglycerides, or proteins without B-complex vitamins. So that should be really, really clear here from this particular table. Now, grains are a very important source of B-complex vitamins, minerals, and fibers. Now, during the milling process, germ, bran, and husk are actually removed from grains. All this leaves behind is the starch-containing endosperm, and many vitamins, minerals, and fibers are lost in this process. In the United States, most products from milled grains are enriched with 4 B vitamins and iron. Those B vitamins are thiamine, riboflavin, niacin, and folic acid. Some examples of foods that are most commonly fortified are cereals and other foods that children are most likely to consume. And this makes sense because if we're talking about kids, we want to make sure that they are getting the B vitamins and minerals that are necessary during the various growth cycles that they are all going through. Now, milled products will still contain numbers of vitamins, but they will be to a lesser extent, such as B6, potassium, magnesium, zinc, fiber, and other phytochemicals. Now, there is a really important recommendation, and this is coming over from my plate. At least half of the grains you consume should be whole grains. Examples of whole grains are brown rice, oatmeal, popcorn, whole wheat bread, and pasta. Now, this is a really important figure because it shows some differences between brown rice and white rice, and also some differences between whole wheat bread versus white bread. One thing that should really stand out is how much more nutrients we find in brown rice as opposed to white rice. And the same goes for whole wheat bread as opposed to white bread. So this is why that recommendation is made, that we really need to be focusing more on making sure that we are getting plenty of whole grains in our diet.